So this is some instruction about material we covered in class last time, but I did it, or last class, but I did it rather quickly. We were also reviewing for the atom test. So I'm hoping that before you watch this video, you've reviewed the PowerPoint demonstrations, or excuse me, the PowerPoint definitions that we went over in last class regarding ionization energy, electron affinity, and electron negativity. So I linked that on the homework site. Please watch that before you watch this video. Now I want to remind you of a thing we talked about last class. We looked at a graph of atomic radius. So I'm going to put AR over here. Now the units could be, usually they're in nanometers these days. And on the x-axis you'd have atomic number. Now remember, atomic number is just number of protons. So I'm going to start with element 3, just making up a place to start. You remember that as you went from element 3 to element 11, excuse me, to element 10, the size goes down. So we'll say this is element 10. Right there, element 10. So that's a 10, that's a 3. Okay, then element 11 over to element 18 looks kind of like this. So there's 18 right there. And that's 11, and that's 18. So you get the idea that as you go from left to right, the size is decreasing. You'll notice that element 3 is lithium on the left side of the table, and element 10 is neon on the right side. This is sodium on the left side. This is argon on the right side. So as you go from left to right, size decreases. And we said the reason for that was that the number of protons was increasing. So as protons go up, let's try that again. As protons increase, size decreases if, this is kind of a big if there are no new energy levels. So as you add the protons, the atoms are going to get smaller. So as you go from 3 protons to 4 protons to 5 protons to 6, it makes the atoms get smaller because the protons are pulling the electrons in tighter since they're opposite in charge. So as long as you don't add an energy level, the atoms get smaller. So you start like this, then you add a proton, it does that, then you add a proton, it does that, then you add a proton, it does that, add a proton, it does that. You get the idea. But when you start a new energy level, they get bigger. And then if you add another energy level, even bigger. So that's what happens. Size gets bigger as you go down, and it gets smaller as you go across. So then that brings us to ionization energy. Do you remember the definition? I'm going to write IE for ionization energy. So it's going to, what will it do as you move from left to right on the periodic table? The atoms are getting smaller. So is it going to be more or less difficult to remove an electron? Okay, it's going to be, as the atoms get smaller, you've got to think, why are they getting smaller? They're getting smaller because you're adding protons to pull the electrons in tighter to the nucleus. So are they being held more here, or are the electrons being held more over there? Well, it seems that the smaller atom is smaller because the electrons are being held tighter. So as you go from left to right, ionization energy increases. Left to right. But as you go down, remember as you add energy levels, I'll draw the energy levels in over here. As you add energy levels, the inside electrons are pushing on the outside electrons. So these guys on the inside are going to push the outside away. So what would happen to ionization energy as you go from left to right, excuse me, top to bottom? It decreases top to bottom, T to B. All right. It's interesting that the electron affinity, remember, what's affinity mean again? Affinity means gaining the attraction for electrons. Okay, so as you go from left to right, what do you think the affinity would do? The atoms are getting smaller. Does that mean the electrons are being attracted more or less? They'd be attracted more. So really the electron affinity does essentially the same thing. Increases left to right. And once again, that's because you're increasing protons as you go from left to right without adding an energy level. If you increase proton and without adding an energy level, things get held tighter. And then from top to bottom, the electron affinity will decrease. Decreases top to bottom. All right. Electronegativity. Electronegativity is similar to electron affinity, except that electronegativity is attraction for a pair of electrons. So it's going to increase left to right, and it's going to do the same thing. It's going to decrease top to bottom. So you may be saying, wait, why do they all have the same trend? Well, they're different definitions. Ionization energy is the energy required to remove an electron. So as the atoms get smaller, more and more energy is going to be required to remove one because the electrons are held tighter. Electron affinity is a measure of the atom's attraction for electrons, as is electronegativity. So both of them would get bigger as the atoms get smaller, because the reason they're getting smaller is because they're attracting electrons. Okay, now they're slightly different in definition. Electron affinity involves the addition of a single electron, and it involves a real measurable energy change. I don't know if you may remember that I said that electronegativity is kind of a made-up scale that takes into account both electron affinity and ionization energy. And it's dealing with a shared pair of electrons as opposed to a single electron, as in electron affinity was. So electronegativity is for a pair of electrons, but still it deals with attracting electrons, and atoms are going to attract electrons more when they're smaller. I'm going to stop this video before it gets too long, and then I'm going to make one more video dealing with energy changes associated with ionization energy and electron affinity.